Hello, my name is Hannah Fowler, and I'm here with Decking Engineering, and today we are presenting our preliminary design report for the Charlton Engineering Office Suite design. Here is a list of our team members and our stakeholders. We will begin this with our structural section, so I will now hand it over to Dylan Loftus.
Hi, my name is Dylan Loftus, and I will be talking about the structural components. The design objectives is to design the layout and design of the columns, beams, and the slab. These are our deliverables and our design considerations. So our two alternatives will be between carbon steel and alloy steel. Carbon steel will be more cost efficient, but the alloy steel outperforms carbon steel in strength, hardness, toughness, wear resistance, as well as corrosion resistance. So by going with the alloy steel, you might pay a little bit more, but it will be a higher longevity, as well as the materials could also be smaller, meaning more room for the structure. This is our system design. On the left is the overhead drawing in AutoCAD. While on the right is through the robot structural analysis. And on there you can actually see the loads being applied. This is our load design. A couple of the calculations done. The left is the dead load design, divided by the roof, each ceiling, and each floor. And the right is our snow load. This is a preliminary cost design. We have not gotten that far yet. We'll be doing that in the next report. So this is just simply breaking down the different items that will be involved in that. This is our timeline, starting with our very beginning with our RFQ, ending with our FDR report and our construction beginning. Next, I will pass it on to the geotechnical component done by Hannah Fowler.
Thank you, Dylan. As I said before, my name is Hannah Fowler, and this is the geotechnical component. Here's the project statement, the deliverables, and the design considerations. There are two alternatives to sell a foundation and a pile foundation. Due to the structural component needing more time to finish their calculations, the calculations for the geotech component are not yet done. The calculations that have been done are using mock numbers or assumed values that will be replaced as soon as the actual values have been calculated. Here's a list of values as well as a sample total settlement calculation. And the sustainability component for the shallow foundation would be recycled aggregate. For the pile foundation, the same concept applies. And then the sustainability component for it would be the energy piled. Thus far, a rough set of calculations have been done, and sample drawings where the numbers can be replaced are currently in progress, as well as cost estimate research. Then shortly thereafter, the reinforced concrete design will be completed, as well as the risk and uncertainty analysis and the final cost estimate and calculation revisions. I will now hand it over to Jonathan for the transportation section. Thank you.
Hi, my name is Jonathan Mink, and I will be doing the transportation component portion of the project. The design objective is to provide a new parking lot for the new engineering building and to show two options that the client can consider. The deliverables for this project will be showing different pavement thickness options for asphalt and for concrete. It'll also show a joint design for the PCC pavement. It'll also have required material amounts along with the concrete mix design for the PCC parking lot, and we'll have cost estimations for both. Design considerations for considering both parking lots are that the total area is 110 foot by 230, so a little over 26,000 square feet. Both parking lots will have a 2% design slope and a 6-inch curb running around the parking lot to help manage storm runoff. The PCC concrete parking lot will have a higher initial cost, but will require less maintenance over time. The flexible asphalt pavement will be a much cheaper option, but it will require more maintenance as time goes on. For the PCC pavement design, it'll be a 20-year design thickness, and it'll be a 5-inch slab. The area of distributed steel reinforcement and tie bar size will be listed and shown. The total area is over 26,000 square feet, so it will require a little over about 405 yards of concrete. Per manufacturer specifications for air and train concrete, it'll be 0.15 fluid ounces per 1% air per 100 pounds of cement. And the batch ingredients required for a yard of the designed concrete are listed here in the table below. For the asphalt design, it will be a much less cost initial cost at the beginning, but maintenance will require crack sealing, new striping, pothole repairs as time goes on. It'll be between a 4 and a 6-inch asphalt design, depending upon what layer of thickness the client chooses. The cost will vary per inch. The design cost for the PCC concrete parking lot will be determined at a later date, along with the asphalt design. And I'll be handing it off to Blake Donahoe to talk about the water resources component. Thank you.
Thanks, Johnny. I'm Blake Donahoe, the lead water resources team member. This aspect of the project was instructed to design a runoff control train, which considered best management practices. This preliminary LID runoff control and treatment train was selected for based upon the decision matrix presented last fall. Here's an overview of that design. It shows runoff being directed towards green infrastructure components. This is a traditional gray water infrastructure overview, and it shows traditional storm drains and inlets. The cost estimation must consider materials, excavation, maintenance, labor, and additional grading. Environmental considerations include the mitigation of mosquitoes, as well as the planting of native species and the treatment of water quality. Social considerations include potential educational possibilities to students at Tarleton. Economic considerations is the potential cost-benefit analysis between green infrastructure and gray water infrastructure. Here's a timeline of this component of the project and its deliverables. I'll hand it off to Noah.
Hi, my name is Noah Eason, and I'm the environmental lead on this project. So Tarleton State University has been instructed to reduce the lead concentration levels from 800 milligrams per kilogram to below 400 milligrams per kilogram before any type of construction can begin on site. We know the lead originated from a lead smeltering factory, which produced lead-acid battery components. And then evidence shows that these fine-sized lead particles were released directly into the air as suspended particles and were carried onto the construction site by wind and rain. So with most in situ processes eliminated from possibility, the best option to preserve the environmental health is to extract the soil and provide remedial practices on site. So remedial option 1 involves the excavation, soil wash, and electrokinetic remediation of the soil. From there, the clean soil will be dried and mixed with new soil and compacted back on site. Remedial option 2 is similar to remedial option 1, except we will only be doing the extraction and soil washing component. From there, the soil will be mixed with new soil and recompacted back on site. And these are the preliminary design deliverables that you can expect for the option 1 cost estimate. And these are the deliverables that you can expect for the option 2 cost estimate. And here's my timeline. Us with Ducking Engineering want to thank you for coming to our presentation today. If you have any questions, comments, or concerns, we look forward to answering them. Thank you.